Now let's practice using division to simplify some roots when the index is greater than 2, but we'll start with an example where the index is a 2. And we've talked about this idea before. Now keep in mind when we have a square root, there really is an index of 2 there. And the idea here is if we divide 2 into 7, that is the index into the exponent, then the quotient is the exponent on the base outside, and the remainder is the exponent of the base inside. So in this case, 2 goes into 7 3 times, so that's going to be the exponent on x outside, with a remainder of 1, so that's going to be the exponent of x inside. That is, 2 goes into 7 3 times, so that's the exponent on the base outside, with remainder 1, so that's the exponent inside. And we don't usually write exponents of 1, so this is how it would look. Try using the idea here. If I divide 3 into 11, I get a quotient of 3, so that's the exponent outside, and then I'll have a remainder of 2. And so that's the exponent on the base inside. Make sure you bring the index of 3 along. It's real easy to forget to bring this, and all of a sudden your roots turn into square roots, even though they don't start that way. How about here? Recalling that 16 is 2 to the 4th. Then for the base of 2, 4 goes into 4 once, so there'll be one factor of 2 outside with remainder 0, so no factors are inside. And then for the base of x, 4 goes into 4 once, so one factor of x will be outside with remainder of 0, so no factors of x are inside. So we just get 2x, and we don't need a radical symbol at all. Sometimes students think if we start with a radical symbol, we need to have one when we end, but that's not the case. How about here? Well, if you prime factor 125, you'll get 3 factors of 5. And since it's negative, I'm going to have 3 factors of negative 5. For the base of negative 5, 3 goes into 3 once, so I'll have a factor of negative 5 outside. And for the base of a, 3 goes into 5 once, so I'll have one factor of a outside, with remainder 2, so I'll have a factor of a squared in the radicand. Try this one. It's kind of hard to look at 48 and see any fourth powers, so I'm going to factor this. And when I do that, I see my prime factorization has 4 2's and a 3. So I'm going to think of 48 as 2 to the 4th times 3. For the base of 2, 4 goes into 4 once, so there'll be one factor of 2 outside with remainder of 0. So there'll be no factors of 2 inside. And for the base of 3, I would need at a minimum 4 factors of 3 to get outside. I've only got 1, so this is going to stay in the radicand. Last, I'll multiply negative 6 and 2 and get negative 12. Here's another. After thinking of negative 27 as negative 3 cubed, and again, if you want to factor this, that's fine. Then 3 goes into 3 once, so one factor of negative 3 will be out. And then for the base of n, 3 goes into 12 4 times, again with remainder 0. So I'm going to have a factor of negative 3 outside. I'm going to have 4 factors of n outside. And then last, I can multiply in any order, and I'll get negative 9 n to the 5th. And here's our last one. Well, I certainly am going to need to factor 168. It has a factor of 2 in it, so I'll start there. And it's 2 and 84. 84 still has a factor of 2, so that's going to be 2 and 42. I'll have another factor of 2, that's 2 and 21, and then 21 is 3 and 7. So my prime factored form is going to be 2 cubed times 3 times 7, which will be 2 cubed times 21. I already have a factor of negative 4 outside. 3 goes into 3 once, so I'll have a factor of 2 outside. Remainder 0, so no factor of 2 is inside. 21 is just inside. And for the factor of y to the 7th, 3 goes into 7 twice, so I'll have y squared outside. Remainder 1, so I'll have one factor of y inside. So again, the factor of 2 comes out. 3 goes into 7 twice, so y squared comes out. The 21 is going to be part of the radicand, and the remainder of 1 means one factor of y will also be part of the radicand. Last, negative 4 times 2 is negative 8. Well, that will conclude this video where we've been using division to simplify roots with indexes greater than 2.